Okay, so let's take a look at a few of the concepts that will be covered in this pre-roll series. So the first one is we are going to create a pre-roll subnet and visibility attributes so that when we select our pre-roll and we're adjusting certain parameters like the pre-hold duration, the rest of pose duration, the inversion duration, the animation duration, we can actually see what's happening because the last thing that we want to do is be adjusting one node somewhere and having to render another node somewhere else, or like let's say handling all of our file imports across our network. Those are possibly FBX nodes, they're limbic nodes, they're all over our network. We want to consolidate those to one node, and then when we select that node, we want to be able to view what we're importing. So our pre-roll subnet is going to have different phases. There's going to be the pre-hold duration, which is how long the initial settle is in rest pose. There's going to be the rest to pose blend duration, which is essentially going from the rest pose to the first frame of anim pose. It's not necessarily going to be the first frame because we're going to compute inversion, which is essentially inverting the overall body locomotion and the per limb locomotion. And so the rest of pose blend is actually going to go to the start of that pose. And then the inversion duration is going to go from that start pose of the inversion to the actual start pose of the animation. And then from there, the animation is going to continue. So then the second topic we're going to cover is going to be converting our rig and animations to Houdini scale for standardized simulations. So what this means is that, our character, let's say that we have a project with multiple different size characters, everything from a small kid to an average man to Hulk to Godzilla, and they all have some sort of muscle or hair simulation, some sort of simulation that requires physically based mathematics in Houdini. So if we have all of those characters at different sizes, that really presents an issue for our simulation. It's going to require a lot of adjustment when we go from different sizes, and unless these characters really interact with each other at the same time, we have the freedom and flexibility to adjust the character scale. So Houdini scale is just an arbitrary scale of some of the test pieces of geometry in Houdini, and it works. A lot of the solvers work pretty good for that scale, but we're going to essentially scale down our asset, our animation to that test geometry scale, and really fine tune our properties for our simulation at that scale, and then learn how we can scale it back up to the original asset size. Okay. The next part is going to be understanding pre-anim, anim, and post-anim time segments. So we've got three phases here, which are essentially, all right, I'll call them time segments because I don't want to confuse them with the phases that were listed in the first bullet point. So time segments. So pre-anim is everything that happens before the actual animation. So those four phases, they're up in the first bullet point. That's going to be pre-anim. Animation is going to be anything that happens during the actual shot, the handles, whatever we get as our input animation or input FBX file, or geocache. And then post-anim is any animation that we add on top of that. So it could be any type of continuation of the anim curves. For the most part, it's probably going to be something like cycle offset, so we can continually loop our input animation and then even simulate on the looping of it. The next part is going to be inverting our animation to automatically generate pre-roll. And so this is going to be really cool. So we're going to use a few of Houdini's nodes to define the difference between our time segments, so we can basically just invert the animation. And if you imagine imagine that time is going from left to right, and we put a mirror right, like let's say the I just dropped my pen. Let's say that the animation starts on 0 and it goes to frame 10. And let's say that, this is a 2D line that's going through space, right? Or 2D plane going through space. Let's say that we put a mirror on frame 0 and we essentially create the reflection of the animation that's happening from 0 to 10. We create the reflection from 0 to -10. And then we're going to be able to choose and adjust that and essentially generate our own inversion so that, imagine if you have a shot with a character where they are in the middle of a punch. The shot starts with the character mid-punch and they're arcing their arm like they're doing like a hook, right? A right hook. You want that to already look correct once the shot starts. Whether it's cloth sliding back, whether it's, skin, or muscles pulling due to the centrifugal force of the arm swinging around. You want that to look correct when the shot starts. And so what we can do is we can take the forward time of that animation and we can just invert it and we can get what would have happened theoretically before. And, while it might not be perfect to artistic sake, it is what we need for, technically generating, the frames to get a physically accurate simulation. And we're going to do this not only on the whole body, but we're going to do this on per limb animation. So again, if somebody's in the middle of throwing a punch or if somebody's running, we might need to offset their entire body. The next thing we're going to do is talk about how we can reduce our locomotion magnitude. And this is going to be for simulation purposes. And what this means is that, imagine that you are animating on, Marvel or DC's next big movie, right? And you've got some superheroes that fly really fast and really far distances. So these superheroes, I hate to break it to you guys, they don't exist in real life, right? So even though they're doing things like flying, incredibly fast, like maybe the speed of sound, speed of light, they're teleporting almost, they're throwing punches and everything's super fast, super intense, super hard. Even though we can imagine this, because Houdini is a physically based simulation, it might not be able to keep up with what these characters are doing. And so, imagine if somebody is running super fast, right? They're like the Flash and they're running super fast. So let's say they cover 100 yards in 10 seconds or so, right? 100 yards in 10 seconds. Imagine just those two numbers, right? So let's say that that's too intense for our simulation. What we can do is we can reduce the 100-yard distance down to 10 yards. So it's 10 yards over 10 seconds. And then we can simulate at that speed and at that distance. And then after the simulation is done, we can re-inject that locomotion so he's actually running, the full 100 yards. And this applies not just for straight lines, but this also this will apply for any type of movement or distance that we have. And this is going to really help our simulation for when we get something where let's say we get just some unusual motion capture, we get something where the animators, it's usually not motion capture because it's done by a real human, which only moves at human speed. But it's usually done when you get certain hand keyed animation where there's frame skips or there's something where they're just trying to accentuate some movement. You get stuff moving faster than it should. So this is going to really help us kind of control our simulation. And the cool thing about this is that we're going to be able to reduce our locomotion magnitude for our automatically generated pre-roll, but also reduce our locomotion magnitude for actual animation and then restore it. So we're going to have a lot of freedom and flexibility here. All right, after that, we are going to take a look at how to automatically compute the best rest pose for any animation and simulation and talk about blending. So what this means is that your stereotypical rest pose is going to be on the origin, right? Your character's modeled on the origin. He's, standing like, let's say 6 feet tall, facing, positive Z, arms out in T pose or A pose. That's where he's modeled, right? That's probably, if you're doing muscle simulation or hair simulation, that's where the hair, that's where the muscles are, right? So that's great, but when you start bringing that character into animation land, all of your animations are not going to start on the origin. They're not going to start at 0, 0, 0. And so somehow we have to get the character to shot space. So origin space is, essentially your rest pose on the origin, and shot space is essentially where the animation starts. And so where the animation starts is not only a position in world space, but it's also an orientation based on the skeleton. Because imagine if you started your zero pose, where your character was modeled, was on the origin, but your animation actually started 100 units behind him and rotated 180 degrees. So he's completely facing the opposite direction, and he's doing stuff really far away from him. You're going to, if you just move your character to that space and in time, you're also going to have to rotate your character to the best position so that when we blend from that position and orientation to shot space, it's not like a weird Euler flip, or long rotation, some sort of gimbal flip. You don't want that. And so we're going to look at how we can automatically move our character plus all of our components, whether that's hair, muscles, skin, to that new shot space rest pose. And that shot space rest pose isn't going to be just the start of our animation, but that shot space rest pose is going to be actually the start of our inverted locomotion and momentum. So really, really powerful stuff here. We're not going to need to ever set up our character blending. It's just automatically going to appear in the right spot so that it has to do the least amount of movement to get ready for the animation, which is going to be great, because there's so many simulations I see where it's blending from rest pose to anim pose, and the arms go through the body, or they twist weirdly, or the whole body twists 180 degrees. It's nuts. You want the least amount of movement to go from your rest pose to your simulation pose, and you want to be able to control pretty much everything about it. Okay. Then what we're going to move on to is colorizing our phases for easy visual feedback and for adjusting settings. So if we take a look at the first bullet point, create pre-roll subnet and visibility attributes, discuss phases. So there are 4 phases there. And if we're just looking at a joint skeleton, it might be pretty hard to understand what current phase the skeleton or the animation is in. So we're going to look at how we can use some vex code, create some parameters, some color ramps, so that we can actually color our skeleton or color our bones. If it's a muscle simulation, we can color this based on the phase, so we can know where our animation starts, how long each of these phases are, and we can more easily adjust this. If we want a longer rest to pose blend duration, we can easily find that color and know exactly when it starts the blend and exactly when it ends the blend. And then, or if we want more inversion duration, we can see that color and we can adjust it. So it doesn't do it justice just to put all these features and hot new stuff in this pre-roll generation. We really need to be able to control it and easily adjust it and see it from a 30,000 foot view. You don't want to be digging in sub networks. You don't want to be jumping all around nodes. You really want to have the fastest visual feedback to adjust your simulation and make the best educated decisions for how to proceed forward. All right, and the last thing that we're going to do is create a viewport HUD to display the time and phase state. So this heads-up display is essentially going to be attached to the hips of our character and move with it through world space, and it's going to kind of go hand in hand with colorizing our phases. So this text that we're going to show is going to be the actual frame number, but based on when our animation starts. So we can essentially see, a negative number counting up to 0, and then frame 1 will be whatever is the and frame one of the actual animation. And then it's also going to have words that will change when the state changes. So, not only are we going to show the frame number, we're going to show the phase that's in, and we're going to show what color of that phase. So we're going to have a really great system giving us a lot of information in the viewport without having to actually look at any specific nodes in our network to figure out what's going on. So let's go ahead and jump into Houdini and take a look at the network.